Alright, here we go. Another problem. Okay. So find the general solution of the given differential. Here's your differential equation. Now, something that you can do to this linear first order ordinary differential equation is that you can get it into this form. dy dx plus some function of x, p of x, y equals f of x. If you get it into this form, which we're going to do, then you can say, you can create an integrating factor that will be equal to that. E raised to the integral of p of x dx. Alright, and then if you multiply everything to the left and right by this formula, then you'll have a separable equation that you can solve. Okay? So, let's do that. Well, first of all, let's stay looking at this right here. Let's rewrite this in a different notation. Here they have y prime. So let's rewrite that as x dy dx plus, let's multiply that x through, x squared plus 2x y equals e to the x. So it's looking more and more like this right now. But what else can we do? We can divide this x squared out. So divide by x squared. So you got dy dx, just like you got here, dy dx, plus x squared over x squared plus 2x over x squared y equals e to the x, x squared. See, what does this simplify to? 1, take out that x, take out that 2, 1 plus 2 over x. So our integrating factor is going to be e, and then the integral 1 plus 2 over x dx, which equals e to the x plus 2 log x, where x is positive. Okay? So, how do we rewrite this? We rewrite this as e to the x, e to the log x squared multiplication. These are inverse functions. You get e to the x, x squared. What's this? That's the integrating factor. That's the integrating factor. That's this right here. We just found px, which is this. You divide, first thing you want to do is you want to divide to make the coefficient of this 1. dy dx, 1. Here it's 1, here it's a squared. Divide it through by that, and I came up with this right here. I got the integrating factor. So, let's keep moving along then. And then, and a real problem is you have to keep track of everything, because if you mess up, it's going to just mess your whole answers. It's not going to come out right if you mess up one little thing. And these are so long, these problems are very long, so you have to keep that in mind. So now we have dy dx plus 1 plus 2x y equals ex x squared. So now let's multiply both sides by the integrating factor, which is e to the x, x squared, e to the x, x squared. So what's going to happen? Well, this is going to go inside here, so we're going to have e to the x, x squared, dy dx, plus e to the x, x squared 1 plus 2x y equals this x squared and this x squared will cancel out. This will equal e to the 2x right there. Now, something that you need to notice real quick, not that you would ever find this on your own, because it would be really difficult to figure this out on your own, but this is actually the result of this. If you were to take the derivative of what is the integrating factor times y, you would get this if you do that out. You just need to keep that in mind. It makes it a lot easier instead of having to do this operation to see that it's correct what I'm saying. So this right here is another way of writing this whole left-hand side here. And then equals e to the 2x. So now what you can do is you can integrate both these sides like this, dx, dx. So this is an inverse function, so it cancels these out. So you have e to the x, x squared, y. The integral and the derivative are inverses of each other, so it takes that all away. Equals, integrate this is just e to the 2x over 2 plus c. Alright? Now you want to solve for y, so you divide by e to the x, x squared. You divide this, e to the x, x squared. Which gives you y equals e to the 2x, 2 e to the x, x squared, plus c, e to the x, x squared. And then you got e to the x here, takes out one of these right here. So you got y equals e to the x, 2x squared, plus c, e to the x, x squared. There is your general solution of the given differential right there.